Hi, I'm Cheryl Leach. The problem we're going to be looking at next is an optimization problem. Let's go ahead and look at the problem itself. I want to find the point on the graph of f of x equals x squared that is closest to the point 2, 1/2. Well, this is a word problem, so we have to determine what exactly we're trying to find. Well, in this case, it's a little tricky because we've been working with optimization problems, but I don't see the word minimum or maximum anywhere in this problem. However, I do notice that I'm trying to find a point that's closest to a given point. Closest would be another way of saying minimize. Well, minimize what? Well, let's see. If I have this point and I'm looking for a point that's on my curve closest, there are a lot of different points I could choose. I could look at this point, or this one, or that one, but I want the one that's closest. And I'm just going to take a guess at it and say it's going to look like it's about there. But a guess isn't good enough. I want to verify and find out exactly what that ordered pair is. Well, again, the question is, what do I mean by closest? Well, if I look at all these lengths, what I'm trying to do is minimize the distance between those 2 points. So I'm going to let the point that's on the curve be just a general point xy and use my distance formula. Well, my distance formula says that I need to take the square root of the difference between the x-coordinates. So this will be an x minus, and in this case, we know that this ordered pair is the point 2, 1/2. So the x-coordinate is the 2. I'm going to square that quantity. Then I'm going to add the difference between the y-coordinates, y minus 1/2, and square that. Okay. Now, let's simplify this a bit. Well, actually, before I simplify it, I notice I have 2 variables here, and that's a problem. I would like to write this as a function of a single variable. So I need to write either x in terms of y or y in terms of x. Well, how could I do that? Well, I know that this point is on the curve f of x equals x squared, which means I know that y and x squared are exactly the same. So let's substitute that in. So I have x minus 2 quantity squared plus x squared minus 1/2 quantity squared. And again, let's do a little simplifying here. I'm going to have the square root of x squared minus 4x plus 4 plus x squared, x to the 4th, excuse me, minus x squared plus 1/4. Combining some like terms, I will have the square root of x to the 4th. I have 2 x squared terms, one positive and one negative, that will add together to be 0. And then I have a minus 4x and a plus 4 and 1/4. So this is 16/4, so that'll give me a total of 17/4. Okay, so I have my primary equation. I have it written all in terms of a single variable. If you want to think in terms of the values I could use for x, looking at my picture, I can see that my x values can be a variety of things, so I really don't have any restriction on it. So I'm ready to take the derivative. Now, before I jump into this, I'm going to simplify my process just a little bit. I know that in order to minimize this quantity that's under the square root, I will accomplish the same thing if I just minimize the piece that's underneath the square root. That's going to make my work a lot easier. So let's try this. We want to just take a look at x to the 4th minus 4x plus 17/4. This is the thing that I would like to minimize. So let's call that z. All right? So I want to minimize this equation. So I'll find dz dx, which will give me a 4x cubed minus 4. I know that I will have critical numbers when that derivative is 0 and when it's undefined. Right? This is a polynomial. It's never undefined, so I don't have to worry about that. But I could run into the possibility where dz dx equals 0. And that's going to happen when 4x cubed minus 4 equals 0. I can factor out a 4. And notice that this is going to happen when either the 4 is 0, which won't ever happen, or when x cubed minus 1 is 0. This happens when x cubed is 1, which happens when x is 1. So this tells me how to break my interval up when I go to use my table. So let's see. I'm going from negative infinity to 1, and then from 1 to infinity. Let's take a test value. Anything you like from negative infinity to 1. Let's try 0. We're going to plug this into the derivative. Okay? This is a nice version of the derivative to try. When x is 0, I'm going to have a negative 1 times 4, which is a negative number, which means that my function is decreasing. Pick anything you like bigger than 1. Let's try 2. Again, plugging it into your derivative. 2 cubed is 8, minus 1 is 7, times 4, that's a positive number, which means I'm increasing. So my function is decreasing, and then it begins increasing again. Decreasing, and then increasing. Okay? On the interval from negative infinity to positive infinity, which tells me that there's a relative minimum when x equals 1. But because of the way the graph is working, and it starts out decreasing and then begins to increase, that relative minimum is also the absolute minimum. So there's going to be a minimum when x equals 1. Well, that doesn't tell the whole story. Remember, I'm looking for that ordered pair. So I'd like to figure out what the y-coordinate is as well. Well, remember, it has to be on that graph, f of x equals x squared. So f of 1, which is 1 squared, is also 1. So that tells me that my ordered pair is the point 1, 1. Now, just as a check, let's go back to my graph and see if that's a reasonable answer. I was estimating that the answer would be right about in that location. And notice this is x equals 1, so if I go up 1 and over 1, maybe it wasn't quite right, but it looked pretty close. Close enough that I trust my mathematics over my graphing abilities. I hope this helps. Thanks.